Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Geometry Unit 5, Lesson 2. The lesson today is called Comparing the Measures of Angles of a Triangle. In this lesson, inshallah, he will give me the lenses of a side and I will compare the angles according to the lenses of the sides. Let's start the lesson. For example, if we have a triangle like this, okay, if we have a side like this and its measure equal 10 centimeters and another side like this and its measure equal 4 centimeters, it's clear that 10 greater than 4. Okay, then AC is bigger than BC. If he give me angle B which is equal 110, for example, of course, and angle A which is equal 30 degrees, for example, also, then we get that the big side 10 opposite to the bigger angle 110 and the smaller side 4 opposite to smaller angle 30. Again, the bigger side opposite to the bigger angle and the smaller side opposite to the smaller angle. Now I can say that in a triangle, if two sides are unequal in length, then the longer or the greater opposite to the angle of greater in measure and the smaller opposite to the smaller, and so on. Okay, now if we have the third side equal 7 centimeters and the third angle equal 40 centimeters, by compare the three sides and the three angles, okay, if I arranged the sides, it will be 4, 7 and 10 in ascending order, 4, 7 and 10. And if I need to arrange the angles, it will be 30, 40, 110 in ascending order. We see that the smallest side opposite to the smallest angle, the middle side opposite to the middle angle, the biggest side opposite to the biggest angle. Again, the smallest side opposite to the smallest angle, the middle side opposite to the middle angle, the biggest side opposite to the biggest angle. Okay, we can classify this theorem as the follow. In a triangle, the longest side in length opposite to the greatest angle in measure and the shortest side in length opposite to the smallest angle in measure. Now, if we have this angle, which is, of course, equilateral triangle. Now, if I need to change the measure of this angle, okay, for example, this angle like this. The angle was 60, change into 50 like this. Of course, if I change this angle, then another angle must be changed like this. Now the equilateral triangle changed into triangle included 60, 70 and 50. Now here this angle equal 60 and this angle 50 and this angle equal 70. We find that the smallest angle in the triangle is less than the ideal number, which is 60. Okay, it is smaller than 60, and the greater angle or the greatest angle greater than the ideal number, which is 60. Okay, greater than 60. Okay, we can classify this one by the follow. The measure of the greatest angle greater than 60, it's an any triangle, and the measure of the smallest angle smaller than 60. Let's start the questions of the lesson. Example 1 here. Arrange the measures of triangle ABC in ascending order. First, I will draw the triangle like this. A, B, and C. Okay. Here we have AB equal 12, BC equals 15, and AC equal 10. Now if I need to arrange the sides, okay, it's 10 in ascending order, 10, 12, 15. 10 is opposite to the smaller angle, the smallest angle, and 12 opposite to the middle angle, 15 opposite to the biggest angle. Okay, therefore angle, since BC greater than AB greater than AC, therefore angle, measure of angle B less than measure of angle C less than measure of angle A, and this is the ascending order. The next one, here in this example, complete the following. Number 1, the length, if the length of two sides in a triangle are not equal, then the greater side in length opposite to greater angle in measure. Number 2, triangle ABC, okay, 7, 5, and 6. Then the smallest angle is, okay, first I'm going to draw the triangle like this, A, B, C. Okay, AB equal 7, BC equal 5, AC equal 6. The smallest angle which is opposite to the smallest side, 5, then angle A is the smallest. 3, DEF, DE greater than EF, I will draw it. D, E, F. Here DE is a big side, EF is a small side. Okay, DE opposite to angle F, then angle F is a greater angle. EF opposite to angle D, then angle D is a smaller angle, then angle, measure of angle F greater than measure of angle D. The next, here example 3. In the opposite figure, AC greater than AB with DB equal to DC, prove that ADB greater than ACD. ABD greater than ACD. Okay. Now I will divide the shape into two triangles as we see. Okay, in the lower triangle here we have angle B equal to angle C because this one is an isosceles triangle. In the upper one, here we have AC greater than AB as we see in the given. AC is the big side and AB is the small side. The big side opposite to big angle, small side opposite to the small angle. Finally, angle ABD is greater than angle ACD because angle ABD formed from big angle and equal angle, and here small angle and equal angle. Okay, now I will start the proof like this. First, in triangle DBC, since DB equal to DC. Therefore, measure of angle DBC equal to measure of angle DCB, and this is number 1. In triangle ABC, since AC greater than AB, therefore measure of angle ABC greater than measure of angle ACB. This is number 2. By adding one and 2, therefore measure of angle ABD greater than measure of angle ACD. The next one, in the opposite figure, XY parallel greater than XZ greater than XL. Again, XY greater than XL, and YZ greater than ZL. Okay, prove that angle L XLZ or angle L greater than XYZ or angle Y. First, I need to divide this shape into two triangles. Then I will connect between angle L and angle Y. Okay, like this, angle L and angle Y like this. Okay, now I have here two triangles, triangle XYL and triangle YLZ. Okay, by looking to the upper triangle, XY bigger than XL. Okay, then angle L greater than angle Y, because angle L opposite to XY and angle Y opposite to XL. Down we have here angle YZ greater than LZ, then angle L greater than angle Y. By adding the two angles here, big plus big, and the two angles here, small plus small, we get that angle L greater than angle Y. Okay. First, in triangle XYL, excuse me, XYL, since XY greater than XL, therefore measure of angle XLY greater than measure of angle XYL, and this is number 1. Okay, number 2, in triangle LYZ, since YZ greater than LZ, therefore measure of angle ZLY greater than measure of angle ZYL. This is number 2. By adding one and 2, therefore measure of angle XLZ greater than measure of angle XYL. The next one, here in example 5, in the opposite figure ABC triangle, as we see, BM bisects angle ABC, CM bisects angle C, where MC bigger than MB. Here MC bigger than MB. This one big and this one small. Okay, then prove that angle ABC bigger than angle ACB. Oh, it's very clear. In the lower triangle, we have here big side opposite to big angle, then angle B is a big one, and the small side opposite to the small angle, then angle MBC here greater than angle MCB here. But MB bisects angle B, then those two angles are equal, and those two angles are equal, then angle B formed from big plus big, and angle C formed from small plus small, then angle B greater than angle C. Now I will start with the lower triangle. In triangle MBC, since MC is greater than MB, therefore measure of angle MBC greater than measure of angle MCB. Okay, therefore two times measure of angle MBC greater than 2 time measure of angle MCB. Okay, since MB bisects angle B, therefore measure of angle B equal 2 times measure of angle MBC. Since CM bisects angle C, therefore measure of angle C equal 2 times measure of angle MCB. Okay, therefore measure of angle B greater than measure of angle C, because I said here 2 measure B MBC greater than 2 measure MCB, and this is required. The next one, example 6, in the opposite figure ABC is a triangle in which AB equal AC and DB greater than DC. Big side, small side. Okay. Prove that ABD greater than ACD. Okay. In the lower triangle, we have here big side and small side. Then we have here big angle and small angle. Again, we have big side opposite to big angle, small side opposite to small angle. But the upper triangle or the exterior triangle is isosceles triangle ABC. Therefore, angle B, the whole of angle B, equal the whole of angle C. Angle B and angle C are equal. If we subtract a big side from C, and subtract a small part from B, then the remainder from here is a small part, and the remainder here is a big part. Again, here angle C equal to angle B. If I subtract a big part from C and a small part from B, then the remainder here is a small part because I subtract big part, and the remainder here is a big part because I subtract a small part. How can I prove this one? First, in triangle BCD, since BD greater than CD, therefore measure of angle DCB is greater than measure of angle DBC. Okay, and this relation I will call 1. Okay, in triangle ABC, since AB equal to AC, therefore measure of angle ACB greater than measure of angle ABC, and this is number 2. By subtract 1 from 2, one from 2, therefore measure of angle ACD, which the remainder from C, smaller than measure of angle ABD, which the remainder from B. Okay, the next example. Here in this example, ABC triangle AB greater than AC. AB is a big side, AC is a small side. XY parallel to BC proves that angle AYX greater than angle AXY. Okay, I will start with this given, AB greater than AC. This given included in which triangle? It's included in the larger triangle. AB here is opposite to angle C. Once AB is a big side, then angle C is a big angle. And AC is a smaller side, then angle B is a smaller angle. Here angle C equal to angle Y, corresponding angles, and the angle X equal to angle angle B equal to angle X, corresponding angles. Since angle C greater than B, then angle Y greater than angle X. Okay, let's prove this one. Since first, in triangle ABC, since AB greater than AC, therefore measure of angle ACB greater than measure of angle ABC. Okay, this is number one. And since XY parallel to BC, therefore measure of angle AYX equal to measure of angle C, and this is called corresponding. And therefore measure of angle AXY equal to measure of angle B, also this one corresponding. Okay, therefore measure of angle AYX greater than measure of angle X. The next example. Okay, this one and this one here. BM is a median, and of course we know that the median bisect the base in triangle ABC. MB greater than MAM. Again, BM smaller than AM. Okay, then this one is a big one and this one is a small one, and since M is a midpoint, therefore AM equal CM. That means AM bigger than BM and CM bigger than BM. Okay, now to prove that angle B is obtuse, we studied in preparatory 1 that in any triangle, if we have three angles 1, 2, and 3. For example, angle 3 is the biggest angle. If angle A1 plus 2, okay, greater than angle 3, then this one represent acute angle triangle. And if angle 1 plus angle 2 equal angle 3, this represent right. Finally, angle 1 plus angle 2 less than angle 3, this represent obtuse. Okay, now I need to prove angle B is obtuse. Then I need to prove that angle B greater than A plus C together. Okay, in the triangle AMB, AM is a big side, MB is a small side, then angle B is a big angle, angle A is a small angle. In triangle MBC, since CM is a big side, MB is a small side, then angle B is a big angle, angle C is a small angle. Then by compare angle B, okay, angle ABC, okay, is a sum of big plus big. By add, therefore, angle B is greater than A plus C, then angle B is an obtuse angle. Okay, I will start the proof like this. In triangle ABM, since AM greater than BM, therefore measure of angle ABM greater than measure of angle A, and this is relation number 1. Okay, in triangle MBC, since MC greater than MB, therefore measure of angle MBC greater than measure of angle MCB. This is number 2. By adding one and 2, therefore measure of angle ABC bigger than measure of angle A plus measure of angle C, therefore angle ABC is an obtuse angled triangle. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.